In this lesson we will present the topic developing specifications for raw materials as part of the Chemistry Manufacturing and Controls course. We will discuss strategies for developing specifications for drug substances, excipients, packaging materials for tablets, capsules, parenteral preparations and semi-solid dosage forms. Lesson objectives. After this lesson you will be able to define the term specifications. Describe the critical tests for drug substances. Be able to discuss what to consider while selecting an identity test. Describe how to justify drug substance specifications. Learn the limits of impurities and residual solvents in drug substance specifications. Discuss how specifications of compeedial and non-compeedial excipients are developed. Describe the general specifications for tablets, capsules, parenteral preparations and semi-solid dosage forms. Discuss the standards and pharmacopoeias of glass, plastic containers and rubber closures. Let's start with specifications for raw materials. Specifications may be defined as list of tests, references to analytical procedures, and appropriate acceptance criteria which are numerical limits, ranges or other criteria for the test described. For example, a buyer may request a supply of vitamin C with the following specifications: melting point, assay, specific optical rotation, oxalic acid content, loss on drying, sulfated ash and residual solvents. Definition of specifications. Specifications describe the standards for products or materials used during manufacturing. Specifications may be classified as raw material specifications, container closure specifications, finished product specifications. In this lesson we will discuss only the first two specifications.
You'll develop specifications of drug substances. The specifications are developed by the manufacturer after product development. The specifications help the manufacturer to find the right vendor. The specifications are used to select the best vendor. Vendor selection involves vendor assessment and selection, vendor evaluation, ongoing vendor evaluation. Where possible, the specifications for raw materials should include names such as international non-proprietary names (INN) and internal code, pharmacopoeia if applicable, qualitative and quantitative requirements and limits. Other information may include supplier name, sampling procedure or reference for sampling procedure, storage conditions, precautions and retest date. Several agreed-upon tests are performed and results should be provided by the selected vendor. For each raw material, the buyer will provide the vendor with the following: acceptance criteria, analytical procedure and the results of analysis. The vendor may give an alternative validated test method that gives the same result which must be acceptable to the buyer. Critical tests for drug substances. The following tests are commonly applied: appearance, identification, heavy metals, moisture, specific optical rotation, assay, residual solvents, related substances found as impurities. Appearance. The color can be an indication of purity and a means to identify contamination that occurred during the synthetic process. Typical testing involves viewing the material against a white background under specified lighting and reporting the color and form. A commercially available color guide can be utilized to develop a robust method to determine the physical appearance of said material. Identification test. This is a specifically discriminating test. For a drug substance it may be an infrared test with a reference standard. The method must be provided by the buyer and agreed upon with the vendor. It could be a compeedial method. Heavy metals. The levels of heavy metals are usually determined using a pharmacopoeia method. The levels should not exceed 20 parts per million ppm. Moisture. Excess moisture can ruin a formulation and cause a rapid deterioration of raw material. The moisture level is established during product development. It should be determined in the drug substance and not exceed the set limit. Specific optical rotation. This applies only to optically active drug substances. It can be used to set specifications and distinguish the drug substance from others. It's not relevant for optically inactive substances. Assay. This refers to the method used to determine the amount of drug substance apart from the impurities. It may be a validated in-house method or a method published in the Pharmacopoeia. The amount of drug substance determined should not be less than the stated level. The assay acceptance criteria of 98.5-101.5% is based on general limits applied to pharmacopoeial items and allows for analytical variation of the HPLC method. Residual solvents. Because residual solvents do not provide therapeutic benefit, they should be removed, to the extent possible, to meet ingredient and product specifications, good manufacturing practices, or other quality-based requirements. Classes of solvents. Solvents to be avoided. All known human carcinogens and strongly suspected human carcinogens with environmental hazards should be avoided by manufacturers of drug substance. Solvents to be limited. Non-genotoxic animal carcinogens or possible causative agents of other irreversible toxicity such as neurotoxicity or teratogenicity should have limited usage. Solvents suspected to have significant but reversible toxicities should have limited usage. Solvents with low toxic potential. For solvents with low toxic potential to man, no health-based exposure limit is needed. These have a permitted daily exposure of 50 mg or more. Related substances. These occur as impurities and should be identified by the manufacturer as much as possible. A suitable analytical method should be used. The method may be an in-house analytical method. Impurities should not exceed the stated levels. Example of specifications. The specification sheet in the following slide includes controls on universal attributes that are generally recognized as critical to the quality of the drug substance, such as appearance, identification, assay, impurities, among others. Other specification may be included. The drug substance is a white crystalline powder. This complies with the specification test. It also complies with the two identity tests. The infrared spectrum corresponds to that of corresponding preparation of the reference standard. The drug substance also responds to the chloride test. It's also in compliance with the heavy metals test that showed less than 20 parts per million. The moisture level also complies. It was not more than 0.5%. The specific optical rotation passed the acceptance criteria. The assay for the drug substance gave a result that was within the acceptance criteria.
This slide is a continuation of the previous slide.
The acceptance criteria for residual solvents show that methanol not more than 3000 ppm, toluene not more than 890 ppm, and tetrahydrofuran not more than 720 ppm. Results of analytical samples shows compliance as they were within the acceptance limits. The acceptance criteria for related impurities shows impurity A, not more than 0.5%. Impurity B, not more than 0.15%. Impurity C, not more than 0.15%. Impurity D, not more than 0.15%. Impurity E, not more than 1.0%. Impurity F, not more than 0.50%. Any unknown impurity, not more than 0.10%. Total impurities, not more than 2.0%. Results of analysis using in-house HPLC method show: impurity A, 0.20%. Impurity B, 0.10%. Impurity C, 0.09%. Impurity D, 0.11%. Impurity E, 0.30%. Impurity F, 0.30%. Any unknown impurity, less or equal to 0.07%. Total impurities, 1.4%. All the impurities were within the acceptance criteria.
In this section we will discuss about justification for the specifications. We can also call it the reasons to justify the specifications. The justification may sometimes be a regulation or a guidance document or a pharmacopoeia. Justification for appearance. A qualitative visual test for appearance should be incorporated into the specification sheet to confirm that incoming batches of the drug substance comply with the description of the crystalline powder as in the previous example or liquid. Justification of the identity test. In the above example, a highly specific test for identity has been incorporated whereby the drug substance is compared to the reference standard via infrared spectroscopy. Testing is based upon USB method. Choose highly specific test for your drug substance. If the drug substance is as a hydrochloride salt, a qualitative test for the chloride counter ion should be incorporated into the specification sheet for product identification. In this example, testing of the chloride counter ion is based upon the USB method 191. The proposed assay acceptance criteria in the previous example of 98.5 to 101.5% is based on general limits applied to pharmacopoeial items. This allows for analytical variation of the HPLC method. The method should be validated for accuracy, precision, specificity, and linearity as per HQ2A and Q2B recommendations, and shown to be stability indicating. Sources of related substances, impurities. In this slide we consider how to list impurities and their origins. Impurity A, you provide its structure. It's a degradation impurity from hydrolysis. It's an active metabolite. Impurity B, you provide its structure. It's a process impurity. Impurity C, you provide its structure. It's process impurity. Impurity D, you provide its structure. It's a process impurity. Impurity E, you provide its structure. It's a degradation impurity from oxidation. Impurity F, structure unknown. It's a process impurity. Sources of related substances, impurities. The impurities are either from the degradation of the drug substance or from the process. The above table shows that hydrolysis and oxidation of the drug substance are sources of impurities. Note that impurities vary with the type of drug substance. The structure of the impurities may be known or unknown. The unknown impurity levels should not increase on forced stability testing. The proposed impurity limits are based upon recommendations in HQ3A. Slide 30. Justification for impurities. Impurity levels in the drug substance acceptance is based on the drug product. For example, the hypothetical drug substance above may be used to formulate a generic drug using a reference-listed drug, RLD. The justification of the impurities is based on the HQ3A qualification threshold and RLD. See next slide. Justification for impurities. This slide is based on a previous slide showing sources of impurities. It shows how to compare the impurities in the drug substance with those in the drug product and the proposed limits for the drug product along with justification for proposed limits. The levels of impurities are below the set levels for the drug product. The limits are based on HQ3A qualification or reference-listed drug. The acceptance of the unknown could be based also on the fact that the impurity F is also present as the reference-listed drug. Evidence could be based on reference-listed drug and a newly formulated generic drug exhibiting a peak with the same retention time on the HPLC, having identical UV spectra, and similar mass spectra. If the maximum daily dose of the generic drug is 64 mg/day, the corresponding recommended identification and qualification thresholds based on ICHQ3A are 0.10% and 0.15%, respectively. Test methods. The test method for the drug substance and related substances test method should be ideally identical to the drug product related substances test method, except for the sample preparation procedures. This helps in the comparison of impurities in the drug substance and drug product. Residual solvents, impurities. The residual solvents utilized in the manufacturing process of the hypothetical drug substance and the proposed levels of these residual solvents in one lot are listed in the table below. Proposed specification limits are based on the recommendations in ICHQ3C, Option 1 limits. Levels are based on a compendial GC test method for residual solvents found in USP. Inorganic impurities. If the drug substance manufacturer indicates that no metal catalysts are used in the manufacture, only heavy metals are to be monitored in the drug substance. The proposed limit of not more than 20 ppm for heavy metals is based upon a general limit applied to pharmacopoeial items. Testing is based on the USP Heavy Metals Test 231 Method 2. Specification of moisture content. If the drug substance is not hygroscopic, less than 0.5% water uptake at 90% relative humidity, and it has no known hydrate forms, moisture may not be critical to the manufacturing process. However, due to the potential for degradative hydrolysis of the drug substance during storage, a specification limit of not more than 0.5% can be proposed for moisture content. Testing for moisture is based upon Carl Fisher titration USB 921 Method 1A. Specific optical rotation. If the drug substance is optically active, for example having a specific optical rotation of plus 67.2 degrees, a specification for this attribute should be proposed as in the above example. The proposed limits of plus 66.4 to plus 68.0 degrees allow for typical variability in the measurement of optical rotation.
In this section we describe specifications for excipients and what you need to know to set them. Excipient specifications and vendor selection. Just like with the drug substance, specifications for the excipients are used to select the most suitable vendor. Vendor selection involves vendor assessments or selection. You may have to carry out vendor evaluation and ongoing vendor evaluation depending on your situation. Classification of excipients. First, we will classify excipients into two categories: competial and non-competial excipients. Some excipients play a critical role in the drug products while others don't. Excipients which exert critical functional roles in controlling the rate of the drug substance release require different type of specifications from others. Controls on excipients which do not exert a functional role is based on specifications defined by the USP nor the National Formulary NF. This slide shows 3 excipients in water which do not exert a functional role from different manufacturers. Water is considered a processing aid. The standards are indicated by NF or USP. They all comply with USP or NF. Compendial excipients which exerts a critical functional role. The compendial excipients such as ethyl cellulose which exerts a critical functional role in controlling the rate of drug release. More stringent specifications than those defined by the USP and NF will be imposed, including controls on viscosity and degree of substitution. The selection of the most suitable vendor will depend partly on the ability to meet specifications and other factors. Non-competial excipients. These are excipients not in any pharmacopoeia, and they include gelatin capsules. The capsule manufacturer must comply with the requirements of the guidance for industry if the application is to FDA. See reference. The sourcing and processing of gelatin to reduce the potential risk posed by bovine spongiform encephalopathy (BSE) in FDA-regulated products for human use. Non-competial excipients. The following shows a sample specifications table for a hard gelatin capsule. The actual specifications will vary with the formulation.
In this last section for this presentation, I will discuss packaging specifications. I will describe the general considerations to be made when you are setting specifications for your packaging material. I will only consider the primary packaging material which comes in contact with the product. Developing specifications for packaging materials. In this section we will discuss basic principles which should be applied in developing specifications for packaging materials of individual products. Tablets should be kept in well-closed containers and protected from light, moisture, crushing and mechanical shock. Any special storage conditions should be stated on the label. Packaging specifications of tablets. Moisture-sensitive tablets such as effervescent tablets should be stored in tightly closed containers or moisture-proof packs, and may require the use of separate packages containing water-adsorbent agents such as silica gel. Packaging specifications of capsules. Capsules should be packaged and stored in a manner that protects them from microbial contamination. Capsules should be kept in well-closed containers. They should be protected from light, excessive moisture, or dryness. Parenteral preparations are usually supplied in glass ampoules, bottles or vials, plastic bottles or bags, and prefilled syringes, which are colored in the case of light-sensitive substances. Except under special circumstances determined during product development, The containers for parenteral preparations should be made from a material that is sufficiently transparent to permit the visual inspection of the contents. The containers should not adversely affect the quality of the preparation, allow diffusion of any kind into or across the container, or release foreign substances into the preparation. Closures for containers for parenteral preparations should be equipped with a firm seal to prevent the entry of microorganisms and other contaminants, while permitting the withdrawal of a part or the whole of the contents without removal of the closure. They should not be made of materials that react with the contents, nor should they allow foreign substances to diffuse into the preparation. The elastomers of which the closure is made should be sufficiently firm to allow the passage of a needle with the least possible shedding of particles. Closures for multi-dose containers should be sufficiently elastic to allow the puncture to reseal when the needle is withdrawn, and thus protect the contents from airborne contamination. A tamper-evident container is fitted with a device that reveals clearly whether it has ever been opened. The container should allow for visual inspection of solutions, reconstituted solutions and intravenous infusions. The solution should be clear and free from visible particulate matter. The exception to this is where there is a dispersion as opposed to a solution. Containers and closures for topical semi-solid dosage forms. Containers for topical semi-solid dosage forms should be made from a material that does not adversely affect the quality of the preparation, or allow diffusion of any kind into or across the container into the preparation. Closures for these containers should be of a design that minimizes microbial contamination, and be equipped with a device that reveals whether the container has ever been opened. Containers for topical semi-solid dosage forms should protect the preparation from light, moisture, and damage during handling and transportation. Applicators and tubes for topical semi-solid dosage forms. The use of suitable metal or plastic flexible tubes is preferred. Preparations for nasal, oral, vaginal or rectal use should be supplied in containers adapted for the appropriate delivery of the product to the site of application, or should be supplied with a suitable applicator. Glass containers. Pharmacopoeia requirements for containers in Europe, Japan and the USA. A classification of different types of glass containers for pharmaceutical products does not exist in the Japanese pharmacopoeia, while those given in the European and United States pharmacopoeias are very similar. Glass containers. Similarities of both the European and United States pharmacopoeias. Provide specifications for glass containers for injections. Give specific guidance for the packaging, repackaging and dispensing of medicinal products. Provide specifications for light-resistant containers and tightly or well-closed closures for capsules and tablets. Glass containers and European Pharmacopoeia. The European Pharmacopoeia gives a general account of the requirements for glass containers for pharmaceutical use, a general account of the requirements for those specifically applicable to glass containers for human blood and blood products. Many different plastics are used for containers for medicinal products and the requirements applicable to them differ greatly in the various pharmacopoeias. It is very difficult to compare the tests described. Other and possibly different requirements may be found in international standards. A comparison of the requirements for rubber closures is as difficult as that for plastic containers. Buyers should refer to relevant pharmacopoeia and test the different rubber closures for suitability before they decide on specification for commercial use. The European and Japanese pharmacopoeias contain special requirements for rubber closures intended for containers of aqueous parenteral preparations. The United States Pharmacopoeia describes more generally the use of closures made from elastomers for injection bottles, but does not specify the preparations for which they can be used. There are similarities between the tests given in the European, Japanese and United States pharmacopoeias, but international standards also exist which differ considerably from one another. Manufacturers should use their product characteristics to develop specification for the rubber closures that meet the respective regulatory agencies. The specifications should be well justified. We have come to the end of the presentation by Royal Canadian College of Distance Education.
Thank you for listening. See you in the next lesson.